Hello students, welcome back. So we are doing exercise 22b from trigonometry, isn't it? And we have completed till question number 9 in our previous video. So today we'll start right from question number 10. Okay, so let's begin. So this is question number 10. If sin a plus cosec a equals to 2, this is the given condition, sin a plus cosec a equals to 2. Find the value of sin square a plus cosec square a. So we are asked to find the value of sin square a plus cosec square a, isn't it? Since we know the formula, a square plus b square equals to a plus b whole square minus 2ab, isn't it? We know this formula from algebra, isn't it? A square plus b square is a plus b whole square minus 2ab. Okay, now let us find the value of sin square a plus cosec square a. Okay, sin square a plus cosec square a. Now let's assume sin a as a and cosec a as b. Okay, sin a as a and cosec a as b. So a square plus b square, isn't it? So we can write this as a plus b whole square, a plus b whole square minus 2a into b, isn't it? Sin a is assumed as a and cosec is assumed as b. Okay, so a square plus b square is a plus b whole square minus 2ab, isn't it? Now we know that since sin theta into cosec theta gives us 1, isn't it? Sin theta into cosec theta is 1 because sin theta is perpendicular upon hypotenuse and cosec theta is hypotenuse upon perpendicular. So when we cancel this h and p, we get 1. 1 upon 1 means 1. So sin theta into cosec theta is 1. Okay, sin theta and cosec theta are reciprocal of each other, isn't it? Similarly, tan theta and cot theta and sec theta and cosec theta. Okay, sec theta and cos theta. Okay, now sin a plus cosec a is given to us. Sin a plus cosec a is 2, isn't it? The value of sin a plus cosec a is given to us 2. So we write sin a plus cosec a 2, okay, whole square minus this 2 we write here into sin a into cos a. So sin theta into cosec theta is 1. So sin a into cosec a is 1. Okay, a and theta are the angle. Angle must be same, theta and theta. Okay, sin theta into cosec theta is 1. Similarly, sin a into cosec a equals to 1. Okay, sine of any angle, sin x into cosec x equals to 1, but sin a into cosec b is not 1. Okay, sin a into cosec b is not equal to 1. Angle must be same, theta theta, a x x. If angles are same, then only we can get the value of sin a into cosec a equals to 1. Okay, the product of sin theta into cosec theta is 1 if the angles are same. If the angles are different, a and b, then sin a into cosec b is not equal to 1. Okay, please keep this in mind. Now 2 squared is 4 minus 2 ones are 2. So 4 minus 2 is 2, isn't it? So we are asked to find the value of sin square a into cosec square a. The value of sin square a into cosec square a is 2. Okay, therefore sin square a plus cosec square a equals to 2. Sin square a plus cosec square a equals to 2. Okay, now let us do the next question. Okay, now let us do question number 11. This question is similar to question number 10. Okay, if tan a plus cot a is 5, find the value of tan square a plus cot square a. So tan a plus cot a equals to 5. This is given to us. We are asked to find the value of tan square a plus cot square a, isn't it? Since we know that a square plus b square equals to a plus b whole square minus 2ab, isn't it? The same formula we are going to use. Okay, since we are asked to find this value, isn't it? tan square A plus cot square A equals to, now let's assume tan A as A, cot A as B. Okay, so A square plus B square, isn't it, which means A plus B whole square minus 2AB. 2A is tan A into B is cot A. Okay, A square plus B square is equal to A plus B whole square minus 2AB. Okay, since we know that tan theta into cot theta equals to 1, isn't it, because tan theta is perpendicular upon base and cot theta is base upon perpendicular. So we cancel this P and P, and B and B, we get 1. 1 is in the right hand side, isn't it? So 1 upon 1 means 1. Now tan A plus cot A, the value of tan A plus cot A is 5 given to us. 5 square minus this 2 we write here into tan A times cot A is 1. Okay, tan theta into cot theta is 1. Angle must be same, A and A. Okay, here theta and theta. So 5 square is 25 minus 2 ones are 2. 25 minus 2 is 23, isn't it? So we were asked to find the value of tan square A plus cot square A, isn't it? The value of tan square A plus cot square A equals to 23. Okay, so this is the answer for question number 11. Let us do question number 12. Now let us do question number 12. Given 4 sin theta equals to 3 cos theta, find the value of sin theta, cos theta, cot square theta minus cosec square theta, and so on. Okay, so the given condition is 4 sin theta minus 3 cos theta, isn't it? So let us write the given condition first. Since 4 sin theta equals to 3 cos theta, isn't it? So this is given to us. Or let us cross multiply and bring this cos theta to the denominator in the left hand side and take this 4 to the denominator in the right hand side. Okay, so sin theta we have here, sin theta. This cos theta will come here, okay, by cross multiplication, equals to 3 is already in the numerator. This 4 will go down to the denominator. Okay, or sin theta by cos theta means tan theta. Okay, please remember tan theta equals to sin theta by cos theta. Sin theta by cos theta means tan theta. Okay, this is the formula. So tan theta, sin theta by cos theta means tan theta. Okay, now this is equals to 3 upon 4. 3 upon 4. Now tan theta means perpendicular upon base, isn't it? Perpendicular upon base. So we have perpendicular, we have base. Now let us find hypotenuse. Okay, applying Pythagoras theorem, we have h square equals to p square plus b square, or h square equals to, what is p? P is 3 plus what is b? B is 4. Okay, base square, or h square equals to 3 square is 9 plus 4 square is 16, or h equals to root under 9 plus 16 is 25, isn't it? Therefore h equals to 5. 5 5s are 25, isn't it? Root under 25 means 5. So we have hypotenuse 5, perpendicular 3, and base as 4. Okay, now let us find the value of sin theta. Sin theta is perpendicular upon hypotenuse. Some people have. So what is perpendicular? Perpendicular is 3. Perpendicular is 3. Okay, p is 3, p is 3, b is 4, h is 5. So p is 3, hypotenuse is 5. So 3 upon 5 is the answer for question number 1. Now cos theta. Cos theta means curly brown hair, base upon hypotenuse, isn't it? So what is base? Base is b is 4, isn't it? So 4 upon hypotenuse is 5. So 4 upon 5 is the answer for question number 2. Now question number 3. Okay, so let me start from here. Okay, so cot theta is base upon perpendicular, so whole squared minus cosec Cosec means hypotenuse upon perpendicular whole square. Okay, so this is B. What is B? B is 4 upon P. P is 3. B is 4, P is 3. So 4 upon 3 whole square minus hypotenuse. Hypotenuse is 5. Okay, upon perpendicular. Perpendicular is 3, isn't it? Whole squared. So 4 squared is 16 upon 3 squared is 9 minus 5 squared is 25 upon 3 squared is 9. Okay, let me continue here. So we have 9 and 9 in the denominator, therefore the LCM will be equals to 9, isn't it? If the denominators are equal, the LCM will be the same number. Now in the numerator we copy as it is, okay, because denominators are equal, so we write as it is 16 minus 25. Now 25 minus 16 is 9, isn't it? 25 minus 16 is 9. The sign of greater number, that is minus, we write here. This 9 we copy here. So 9 and 9 cancels, okay, 9 ones are 9, 9 ones are 9. So we have minus 1, isn't it? So this is minus 1. The value of cot square theta minus cosec square theta equals to minus 1. I hope you got this. Now let us do question number 3 of 12, okay. Question number 3 of 12. So we are asked to find the value of 4 cos square theta minus 3 sin square theta plus 2. Okay, we have perpendicular 3, base 4, and hypotenuse equals to 5. Okay, so this equals to 4 cos theta means base upon hypotenuse, curly brown here, isn't it? So base upon hypotenuse whole squared. So we have a square here, minus 3 we write here. Sin theta means perpendicular upon hypotenuse. Some people have, isn't it? Perpendicular upon hypotenuse. So we have a square here, we put a square, plus 2. Now let us put the value of B, P, and H. Okay, so what is B? B is base, base is 4. So 4, hypotenuse H is 5. Okay, whole squared minus 3. What is P? P is perpendicular, perpendicular is 3. And what is hypotenuse? Hypotenuse is 5. Okay, whole squared plus 2. This gives us 4 into 4 squared is 16, 5 squared is 25, minus this 3 we write here, into 3 squared is 9, 3 3s are 9, 5 squared is 25, plus this 2. Okay, now this 25 and 25 same number, isn't it? So the LCM will be 25. So we write 1 in the denominator of 2, because if there is no number in the denominator, we should understand there is 1, isn't it? So 25 ones are 25, 1 into 16, isn't it? 1 into 16 is 16. Now we have 4 into 16. So 4 into 16 is 4 6 are 24. Okay, 4 ones are 4, 5 6, 64, minus, so 25 ones are 25, that 1 into 9 is 9. Okay, 9 into 1 is 9, into we have 3 here, 3 into 9 is 27, plus 1 into 25 gives us 25, so 25 2s are 50. Now 64 is positive, 50 is positive, 27 is negative, isn't it? Let's add up these two positive numbers and subtract 27. So 4 plus 0 is 4, 6 plus 5 is 11, 4 plus 0, 4, 6 plus 5 is 11, minus 27 upon 25, isn't it? Let me continue here. Okay, so 114 minus 27, isn't it? This is positive, this is negative. So 7 cannot be subtracted from 4. 14 minus 7 is 7. This gives us 7. Now this becomes 10, isn't it? So 10 minus 2 is 8. 87 upon 25. Okay, so we cannot cancel this number, isn't it? So this is an improper fraction. Let's convert this into mixed fraction. 87 into divided by 25. Okay, 25. 25 3s are 75, isn't it? 25 3s are 75. So 7 minus 5 is 2. This is 8. 8 minus 7 is 1. So 3 whole, this 3 quotient we write here, 12 in the numerator, okay, this remainder in the numerator, and divides the 25 in the denominator. So this is the answer for question number 3. 4 cos square theta minus 3 sin square theta plus 2 is 3 whole 12 upon 25. Okay, I hope you got this. Now let us do the next question. Question number 13. Given 17 cos theta equals to 15. This is the given condition. We are asked to find the value of tan theta plus 2 sec theta. Okay, this question is similar to question number 12, isn't it? Now, since the given condition is 17 cos theta equals to 15, okay, or cos theta equals to 15 is already in the right hand side. Let us take this 17 to the right hand side. It goes to the denominator by cross multiplication, isn't it? So cos theta equals to 15 upon the 17 goes here. Now cos theta is base upon hypotenuse, curly brown here. So we have base equals to 15, hypotenuse equals to 17, and perpendicular is unknown to us, isn't it? Applying Pythagoras theorem, since p square equals to h square minus b square, this is Pythagoras theorem, isn't it? Or what is p? P is unknown to us. What is h? H is 17 squared, okay, minus what is b? B is 15 squared, isn't it? Or p squared is equals to 17 squared means 17 17 ja 289, minus 15 squared means 15 15 ja 225, okay. Or p equals to 9 minus 5 is 4, 8 minus 2 is 6, 2 minus 2 is 0. We don't need to write that, okay. Let's take this square to the right hand side, becomes root under. Therefore p equals to root under 64 means 8. 8 is a 64, isn't it? So we found perpendicular 8, base was already given to us 15, hypotenuse 17. Now let us find the value of tan theta plus 2 sec theta, okay. Since tan theta plus 2 sec theta equals to, tan theta means perpendicular upon base, okay, plus, this plus we write here, 2 we write here, sec theta means hypotenuse upon base, just the opposite of cos theta. Cos theta is base upon hypotenuse, curly brown here, isn't it? Sec theta is just the opposite of cos theta, hypotenuse upon base. Now what is p? P we found, p equals to 8, isn't it? B was already given to us, b is 15, okay, plus this 2 we write here, into hypotenuse is 17, isn't it? And b is 15, okay. Now let us take the LCM of the denominators, 15 15, same number, isn't it? The LCM will be 15. Now since the denominators are equal, so we don't have to multiply with any number. We multiply with 1, but that doesn't affect anything, okay. So 8 into 1 gives us 8, plus 17 into 1 gives us 17. That 17 into this 2, we shouldn't forget this, okay. 17 into 2 is 34, isn't it? 34. 2 7s are 14, 2 1s are 2, plus 1 is 3. Now 34 plus 8, that is 42, isn't it? 8 plus 4 is 12, 2, 1 in hand, 3 plus 1 is 4 upon 15, okay. Now let's cancel with 3, okay. 3 5s are 15, 3 1s are 3, 4, 1 in hand, 3 4s are 12. Now we cannot cancel 14 and 5, so let's divide to make mixed fraction, since this is an improper fraction, isn't it? So 14, isn't it? 14 upon 5. 5 2s are 10. 4 minus 0 is 4. So the answer will be 2 whole. This 4 goes to the numerator, 4. This 5 divisor comes down here. So tan theta plus 2 sec theta is 2 whole 4 upon 5, okay. Now let us do the next question. Question number 14. If 5 cos A minus 12 sin A equals to 0, okay, this is the given condition. We are asked to evaluate the value of sin A plus cos A upon 2 cos A minus sin A. We are asked to find the value of this expression, okay. So let us do this question. Given condition, since 5 cos A minus 12 sin A equals to 0. This is the given condition, isn't it? 5 cos A minus 12 sin A equals to 0. Now let us take this 12 sin A to the right hand side, okay? 5 cos A equals to 12 sin A, isn't it? Now we have 5, let us bring this 12 to the denominator here. 12 equals to sin A is already in the right hand side, sin A. We take this cos A to the denominator by cross multiplication, okay? Cos A. This 12 comes down here, this cos A goes down. Therefore, sin A upon cos A means tan A, isn't it? We know that since tan theta equals to sin theta by cos theta, isn't it? This is the formula, tan theta equals to sin theta upon cos theta, okay? Because sin theta is perpendicular upon hypotenuse and cos theta is base upon hypotenuse. So we cancel this hypotenuse, perpendicular upon base. Perpendicular upon base means tan theta, isn't it? So sin A upon cos A is tan A, okay? Sin A upon cos A is tan A equals to 5 upon 12, isn't it? Now this sin A upon cos A is tan A, okay? This 5 upon 12 is here. Now we have perpendicular upon base. So perpendicular is 5, base is 12, hypotenuse is unknown to us, isn't it? Now let us find hypotenuse applying Pythagoras theorem. Since h square equals to p square plus b square, isn't it? H square equals to, what is p? P is 5, p square plus b square, base is 12. So h square equals to 5 square is 25 plus 12 square is 144. H equals to 25 plus 144 is 169, okay? Now we take this square to the right hand side, becomes root under. Therefore hypotenuse equals to root under 169 means 13. 13 is 169, isn't it? So we found hypotenuse as 13, perpendicular was given to us 5, base is 12, okay? So instead of question mark we write 13, hypotenuse is 13. Now let us find the value of this expression, sin A plus cos A upon 2 cos A minus sin A. This gives us sin A is some people have perpendicular upon hypotenuse, isn't it? So what is perpendicular? Perpendicular is 5, hypotenuse is 13. So 5 upon 13 plus, what is cos A? Base upon hypotenuse, curly brown here, base is 12, hypotenuse 13. 12 upon 13 whole upon 2 cos A. 2 into cos A means base upon hypotenuse, base is 12, hypotenuse 13. 12 upon 13 minus, this minus we write here, sin A. Some people have perpendicular upon hypotenuse, perpendicular is 5, hypotenuse is 13. 5 upon 13, okay? Now we take the LCM of the denominators, 13 and 13. The LCM will be 13. Since the LCM denominators are equal, so we write the numerator as it is, 5 plus 12 whole upon, we take the LCM of the denominators, 13 and the LCM will be 13. Now since the denominators are equal, so we write the same numbers in the numerator, 12 minus 5, okay? So 12 into 2 gives us 24, 12 2 is 24 minus 5. Now this 13 and 13 can be cancelled, okay? 13 cancels out, so 5 plus 12 is 17, 24 minus 5, 24 minus 5 is 19, isn't it? 24 minus 5 is 19, so this is the answer, okay? The value of sin A plus cos A whole upon 2 cos A minus sin A is 17 upon 19, okay? I hope you got this. Okay, this was for today. Thank you so much. Stay connected, okay? I'll upload the rest of the questions in the next video. Thank you so much.